In this video, we discuss learning outcome number 2 from lesson 6.2, which is all about finding areas or probabilities given a range of values for a continuous normally distributed random variable x. So we'll motivate this with an example. It says, heights of men are normally distributed with a mean of 68.6 inches and a standard deviation of 2.8 inches. Find the percentage of men who are taller than a shower head at 72 inches. When I first read this problem statement, I immediately thought of Buddy the Elf from Elf. It's one of my favorite Christmas movies. Poor Buddy is a human in an elf's world, and so he's way too big for his shower. That is basically what we're asking over here. We're saying if a typical shower head is 72 inches tall, and the mean height of men is 68.6 inches, and the heights of men are normally distributed with a standard deviation of 2.8 inches. How many men are going to be in Buddy's position here? What is the percentage of men who are going to be too tall for their shower? So these statistics, or actually these population parameters, are not appropriate for ELF, but they're appropriate for men. I think in the US, I think that's where that data comes from. Okay, so in order to answer this question, we are going to need to find areas corresponding to a range of x values. Now, if you're looking at this and you're saying, how do you know that I was supposed to find an area? Well, notice what the question says. It says, find the percentage of men who are taller than a shower head at 72 inches. So they're saying that the men are 72 inches or inches tall or more than 72 inches tall. So they're giving us a range of those heights, and we're asked for a percentage or a proportion or a probability. So that means we want areas under the curve. So if I want to find an area, this is the first thing I'll do with all of these problems. I will immediately sketch a normal curve. I will label the mean and then any specific x values that are mentioned in the question, and then I'll shade the region that represents the desired probability. And then if there were x values in the question, I will convert those to z-scores using this formula. You just take the x value, you subtract the population mean, and you divide by the standard deviation. And then we'll find the corresponding area of the shaded region. We can do that using technology. You could use software or a calculator. I'm going to show you how to do that using Excel or using table A2. That's our table of z-scores. Now remember, the areas represent probabilities. So when you're finding areas, you're finding probabilities. Okay, so let's go back to this question. The first thing we do is we sketch a normal distribution and shade the area of interest. Now I actually already started to do this. I'll share my paper with you. So I draw my curve. I was told that the mean is 68.6 inches, so I just label that in the middle, 68.6 inches. And I'm interested in men that are taller than 72 inches. So I label 72 inches down here on that horizontal axis. And since I'm interested in men that are too tall for that shower, I'm shading to the right rather than shading to the left. Now remember, the area under this curve here is the probability that a man is more than 72 inches tall, or it's the probability that x is greater than 72 inches. If I can find that area, then I can answer this question. Let's go back to the PowerPoint. So we do that. Now this area has already been labeled for us, but we'll get to that in a bit. Then after you've done this, the next step is to convert that x equals 72 inches to the corresponding z-score, because I don't have a table of values, or I don't have a table that gives me areas corresponding to x values, but I do have a table that gives me areas corresponding to z-scores. So I'm going to take this x value, x equals 72 inches, and convert to the corresponding z-score. Because I'm using table A2 as one method for solving this problem, I will round to 2 decimal places. So I want to convert x equals 72 inches to the corresponding z-score. So I have z equals the x value minus the mean divided by the standard deviation. So I've got 72 inches and I'm subtracting the mean of 68.6 inches. These are all in inches. And then I'm dividing by the standard deviation. And I believe that was 2.8 inches. So then we subtract 72 minus 68.6, and then we divide by 2.8. We get 17 over 14. And I want a decimal approximation, so that's about 1.21. Now notice I have inches minus inches here, so that's inches in the numerator, and I'm dividing by a standard deviation, also in inches. So z-scores are unitless. This is a count. It does not have a units of inches or anything else. This is telling me how many standard deviations we are above the mean. So this is a deviation from the mean, and then when we divide by that standard deviation, it tells me how many of those standard deviations I am above the mean, and it turns out to be about 1.21. So this area here corresponds to this area here. Not doing a very good job making these look normal, but I hope you get the idea. So this is z equals 1.21, and because this is a standard normal distribution, this one has a mean of 0. So that green area up here is supposed to be equal to this green area down here. Now my second picture does not look the same, but theoretically those are supposed to be the same curve. Okay, so I need to find this area. Let's go back to our PowerPoint. Oops. So we have that mean, that standard deviation, and then we just do x minus the mean divided by the standard deviation, and we get 1.21. That's 1.21 standard deviations above the mean. And then the last thing we do here is we find the area. Now with Excel or my table, I'm not actually able to find this area to the right, not directly. My Excel program and my table will only give me area to the left. And that's okay. We're going to start with using Excel. So remember how we do that in Excel. If we want area to the left, we use this function norm.gist, and then you've got some values of variables to enter in these parentheses here. You'll need to enter the x value, the corresponding mean, the mean of our normal distribution, the standard deviation of our normal distribution, and then the last entry is asking you if you want cumulative area to the left, and you're always going to say true. And then you will find an Excel output for the area to the left. So let me show you how to do that. So we'll enter equals norm.dist, and then it even tells you, it reminds you right here that they want the x value, which is 72 inches, and the mean of this normal distribution is 68.6 inches. The standard deviation is 2.8, and we want the area to the left. And that's not our answer, but that is telling us that the area to the left is approximately 0.886768, and so on. So the area to the right is going to be 1 minus that answer. So I'll just type equals 1 minus, and I'll select that cell here, hit return or enter. And then according to Excel, if I round to 4 decimal places, this area is approximately 11 or 0.1123. And that's what I mentioned on my slide here. So we calculated this area, and you'll just do 1 minus that. And you don't even have to write it down if you want to. You can just use Excel to say 1 minus the area to the left is the area to the right, and we get this 0.1 or 0.1123. Okay, now it will be less accurate, but you can use your table of z-scores to find the area as well. So we already found the area z, or the z-score, z equals 1.21. Now that's an approximation. We're only rounding to 2 decimal places because we only have 2 decimal places of our z-scores in our table. But if I have the z-score and I've got my table, what I want to do next is I want to find the area to the left of that z-score. Z equals 1.21. So I want to go to the positive z-scores. And then remember how we do this. We're looking in this left column here. And first we're looking for 1.2. So 1.2 is on this row. And then the columns over here give you the hundredths place. So this is 1.20. That's the area to the left of 1.20. And the area to the left of 1.21 is labeled in the table as 0.8869. So I have this area to the left, and it's an approximation. It's an approximation based on the fact that this z equals 1.21 was also an approximation. We had to round here. So that rounding here is leading to a little bit of an error there. But then this area has to be 1 minus the area to the left, because the total probability has to be 1, right? And we get 0.1131. Now notice, when I used Excel and I used this exact X value with this exact mean and the appropriate standard deviation, I got an area to the right of 0.1123. When I used this decimal approximation of z, it led to an error in my area to the left, and the error in my area to the left led to a slight error in the area to the right. So we don't have the same answers here, but that's okay. This one is slightly more accurate. So if I'm trying to be accurate, I would want to use technology to get this answer. But if I am limited by the fact that I'm using a table, then this is close enough for us. So we would say that the area to the right is 0.1131 according to our table. And for an exam, either one of these would be fine. Let's go back to our Excel spreadsheet, or not Excel spreadsheet, sorry, back to our slides. So we find the area to the left, and then the area to the right is 1 minus the area to the left, and so we get that 0.1131, and it's less accurate because we had to round the z-score to 2 decimal places in order to use the table. Okay. Now the last thing is just to interpret what we found. The question asked what percentage or proportion of men are taller than that 72-inch shower head. And it turned out to be 0.1123. That's the more accurate number that we found using Excel, or 11.23%. So if a shower head were designed to be 72 inches tall, 11.23%, or about 11% of men, might find the design unsuitable because they'd be in the same category that Elf is, trying very hard to find a way to get the water over their head when they're just a little bit too tall for their shower. So that is how we find probabilities or areas given a range of X values. You'll note that it is pretty much the same process that we followed when we were finding probabilities or areas corresponding to a given Z value. We just add this extra step. Now when we have an X value, we have to convert it to a Z value first, and then we do everything that we did before in lesson 6.1. Now in the next lesson, we are going to know an area or know a probability that we're trying to find, and then we'll find the X values that are associated with those areas and probabilities. So basically we're going to do what we did in learning outcome number 2, but backwards. I'll see you for that in the next video.